Today we're going to talk about Scanaline's role in the guiding of continuous strip processes.
When was Scanline first used to guide a continuous strip?
In 1984 we had just introduced a complete strip width measurement system, and we installed the first one at Warren Consolidated Steel in Warren, Ohio. Our Scanline sensors were installed at the top of a cooling tower on a hot dip galvanizing line. The system worked beautifully and sent continuous strip width measurements back to the operator's pulpit. After several weeks of operation, we received a call saying that the digital display was flashing occasionally to indicate a video fault. The width readings appeared to be accurate, but the fault condition was worrisome. A quick service trip to Warren revealed the problem right away. I climbed the cooling tower to have a look at the Scanline sensors, and I was surprised to see a thick layer of zinc oxide powder covering the emitter lenses. In fact, I could barely detect the faint glow from the LED arrays underneath. The system was still accurately measuring the strip width most of the time. When I invited the operator to have a look at the top, he came down shaking his head. He commented, "That's amazing. Do you suppose you could guide the strip under these same conditions?" Although I recommended a simple air blow-off to keep the lenses clear in the future, I said that anywhere we could measure width with a Scanline, we surely could guide. I designed and built and delivered a prototype guide amplifier 2 days later. It was a very basic device that took the centerline analog from the Scanline sensors and amplified it to a plus and minus 10 volt drive signal for the proportional valve in the hydraulic system. It had only 2 controls, a gain and an offset adjustment. We called this original design the PCA, or Process Control Amplifier.
Was this original design a success?
Absolutely. Over the next 10 years, we sold several hundred guide systems to many different industries, and some of the original process control amplifiers are still in operation. After several years, we added the proportional, integral, and derivative terms to the PCA amp and renamed it the PID controller, but it was still basically the PCA amplifier. Over the next few years, our customers challenged us with more and more complex guiding situations. We built most of the needed features into the digital to analog converter boards that were used to convert the time pulses from the Scanline sensors into analog control signals. Among the new options that we added was the auto zero function that permitted retargeting the strip position with the push of a button. We also developed a converter board to operate only on the first and last edge detected, regardless of holes or breaks in the guided strip. This later became part of our transparent strip width measurement system. Although these systems worked very well, they began to be a problem because of the many variations required to accomplish the variety of guiding applications. Our simple PCA now had a list of changes required for each sales order. There was virtually no interchangeability between PCAs delivered to the field. In our first attempt to solve this problem, we developed the Model G CPU. In this design, all of our analog input signals were immediately converted to digital format, and all parameters would then be controlled by our firmware. We soon realized that there would be a need for different analog to digital interfaces for the many types of transducers used in a guide system. Different video signals from Scanline would require special interface ports to send the measurement information to the main processor. Special interface boards would require special software drivers. And although the DCPU was able to fulfill its mission of doing nearly every application that we were aware of, it still required major hardware and software changes to make this happen. Our shortcomings became apparent when our customers tried to move a DCPU from one application to another in their plant. Changing a DCPU function and application almost always required a trip back to our facility for us to select the right interface boards and connect them to the proper firmware for the operation.
So tell us about the Model GPX. How well has it accomplished the goal of a universal guide controller?
So far, the Model GPX is looking great. We can accept inputs from any of our Scan-A-Line analog or digital sensors. This does require a selection of either the analog or digital input harness, since the connectors are different. Other than that requirement, the GPX can accept inputs from a EG30, a new low-cost Scanamizer analog sensor, or any of our digital 10x AS sensors, and that would include the 10, 20, 30, 40, or 50-inch emitters. This is the front panel of the Model GPX, and as you can see, all the controls that an operator is likely to need are available right here on the front panel on sealed switches that will not, they're waterproof, oil-proof. They should last for a very, very long time. The bar graph display up above here is showing us the position of our strip, which is off-center to one side. Notice it has also a green light in the center indicating that our video quality is good enough to guide with. We don't have any video faults. If the strip goes too far off center to limit minus or limit plus, which is an adjustment that could be made on a bar graph, the excess error limit relays would fire, giving you an opportunity to send that back to a PLC or whatever and discontinue guiding because the system has gotten away from itself. Down below we have our automatic and manual switch, and we're in the manual mode right now. And from the manual mode, it's possible for us to jog in or jog out. Auto zero, which would pick this present position of our strip and lock that in as our target when we go into the control mode, automatic. And then auto center, and auto center, when we go into automatic, will bring the mandrel right to the center of its operating position, which is a good way to start up a line, making sure you thread that mandrel where you have the most control over it. I'm going to go out of that right now. Also, we have a guide A and B, or center guide. Right now it's in the center guide mode, and the A and the B are both lit up. You can't see them, but if we press the button once, you'll see we're in the B mode right now. Press the button again, and we're in the A mode. And this would allow us to guide from either the A edge or the B edge of our strip. If one of the edges is badly damaged, you can guide with the other one. Or if both strip edges are okay, you go ahead and press the button once more and you're in the center guide mode. So pretty near everything you need is on the front panel. There is a gain control inside and an offset control that can be used for various purposes. But this is not something that is ordinarily adjusted once the system is set up for the first time. Now, all of these functions can be selected from the sealed front panel without any circuit or software modifications. All system settings are stored in non-volatile RAM in case of a power interruption.
What sort of output signals does the Model GPX provide?
Well, our first GPX was designed for the roofing industry, and there was a requirement here to operate an electric actuator for strip steering rather than hydraulic. Hydraulic fluid poses serious quality problems in the roofing industry and also in most rubber products. To this end, we developed a pulse width modulated H-bridge output to directly drive a 24-volt actuator at high current. The H-bridge can also directly drive a proportional hydraulic valve if we simply add some current limiting resistors. Furthermore, we provide a plus or minus 10-volt analog output for input to a PLC or a servo control amplifier. So we've pretty much covered all the applications that we see in the field with our guiding systems with the new GPX. And so far it's doing a great job.